There is no need to follow this closely. Tonight we are going down, not quickly. The ocean does not do anything quickly. We will start at the surface where the moon is, and we will sink slowly through the water until there is no light left at all, and then we will keep going. It will take a few hours. That is the correct amount of time. In the real ocean, a particle drifting down from the surface can take weeks to reach the bottom. Nothing frightening lives down there. That is mostly a story we tell ourselves. What actually lives in the deep is small, slow, patient, and almost entirely uninterested in us. The water will get colder as we go. The pressure will get heavier. The light will go from silver to a blue so dark it stops being a color, and then to nothing. If you fall asleep before we reach the bottom, that is fine. The bottom has been there for a very long time. It will still be there. Let's start on the surface, on a calm night, far from any land. The surface of the open ocean at night is not flat. It moves in long, low swells that have traveled a very long way. A swell you see tonight may have been made by wind in a storm 1,000 miles from here, days ago. The storm is over. The water is still carrying the message. The moon lays a path across it. The path is not really a path. It is thousands of separate reflections on thousands of moving faces of water, arranged in a line because of where you happen to be standing. If you moved, the path would move with you. It belongs to the viewer, not to the sea. This top layer, from the surface down to about 200 meters, is called the Sunlit Zone. Almost everything you have ever seen alive in the ocean lives here. It is a thin skin. If the ocean were the height of a 10-story building, the Sunlit Zone would be the doormat. In daylight, this water is a factory. Drifting plants too small to see, phytoplankton, take sunlight and carbon and turn them into themselves. They are the beginning of nearly every meal in the sea. They also make a great deal of the oxygen in the air you are breathing right now, roughly half of it by most estimates. Every second breath you take began in water like this. At night, the factory is quiet, and something else happens instead. Every evening, all over the world, an enormous number of small animals rise from the deeper water toward the surface. Tiny shrimp-like creatures, small squid, little fish with rows of light organs along their bellies. They spend the day a few hundred meters down, hiding in the dark from anything that hunts by sight. And at dusk they climb. It is called the Deal vertical migration, and it is the largest movement of animals on Earth. It happens every single night, in every ocean, and almost nobody is awake to see it. They come up to feed on the plankton in the dark when it is safer. Before dawn, they sink back down, up at dusk, down at first light. over and over for as long as there have been oceans and something to eat in them. Early sonar operators used to see it and were confused by it. Their instruments showed a solid floor at around 400 meters, and then at sunset, the floor would rise. They called it the deep scattering layer, and for a while some people wondered whether the sea had a false bottom that moved. It was not a bottom. It was animals. Uncountable numbers of them lifting together in the dark. Above them, on the surface, the night is mostly quiet. A seabird might be sitting on the water, sleeping with half its brain at a time. Flying fish sometimes break out of a swell and glide for a surprisingly long way before dropping back in. In warm water, patches of the sea can glow faintly blue when disturbed, tiny organisms flashing when a wave breaks or a hull passes. Sailors have written about it for centuries. Some described whole ships trailing cold fire. The water here is warm at the top and gets colder as you descend, but not smoothly. At some depth, a few tens of meters, sometimes 100 or more, the temperature drops quickly over a short distance. That layer is called the thermocline, and it acts almost like a lid. Sound bounces off it. Nutrients have trouble crossing it. Divers feel it as a sudden cold band around their legs. We are going to sink through it now. Below the thermocline, the light begins to change in a way that is hard to describe until you have seen it. Red disappears first. Red light is absorbed within the first few meters, which is why blood looks green underwater in old diving footage. Then orange, then yellow, then more slowly green. Blue is the last to go because blue light scatters least and travels furthest through water. So the deep sea is not dark all at once. It becomes blue, then a deeper blue, then a blue that is more like a memory of blue. At about 100 meters, on a bright day, you can still read a book. At 150, you would have to hold it close. At 200, on the clearest day in the clearest water, there is only a faint blue glow above you and darkness in every other direction. That is where the sunlit zone ends. There is no marker. Nothing changes suddenly. You simply notice at some point that there is no longer enough light to grow anything, and that everything living around you is now living on food that fell from somewhere else. The water is around 10 degrees now. It will keep getting colder. From 200 meters down to about 1,000, the ocean is in permanent twilight. Scientists call it the mesopelagic, the Middle Sea. It is the largest twilight in the world, and it is almost entirely unstudied compared to anything on land. The animals here are small, soft, and difficult to bring up alive because they tend to come apart when the pressure changes. There is light here, but not much, and almost all of it is coming from directly above. That single fact shapes nearly everything that lives at this depth. If light only comes from above, Then anything solid casts a shadow, and a shadow is a shape, and a shape is a meal. So the animals of the Twilight Zone have spent a very long time learning how to have no shadow. Some solve it by being transparent. There are squid here you could read through. There are jellyfish so clear that the only visible part is the food inside them, drifting along like a small stolen shape. There are larval fish that are essentially water with a spine. Some solve it with silver. Hatchet fish are thin, flattened, and mirrored on both sides, so that light striking them from any angle is reflected back into the blue and disappears. Standing beside one, you would mostly see ocean, and some solve it in a way that took biologists a while to understand. They glow. It is called counter-illumination. A fish hanging in the Twilight Zone has rows of small light organs, called photophores, along its underside. Those lights are tuned to match the faint blue light coming down from above. From below, a predator looking up sees an even blue field with no dark fish-shaped hole in it. The animal has erased its own silhouette by producing exactly the amount of light it is blocking. Some of them can adjust the brightness as the light above them changes. Some can dim on one side. It is one of the most elegant tricks in the ocean, and it is happening right now, in the dark, in every ocean on Earth, in numbers we cannot really count. Which brings us to something worth saying slowly. Most animals in the sea can make light. Estimates vary, but a commonly cited figure from deep-sea surveys is that roughly 3/4 of the animals in the open ocean are bioluminescent. On land, glowing is a curiosity. Fireflies, some fungi, a few glowworms in a cave. In the ocean, it is ordinary. It is the normal way to be. The light is almost always blue-green. There is a good reason. Blue-green travels furthest in seawater, so a signal made in that color reaches the largest audience. A red glow would be swallowed within a meter or two and wasted. A few animals have gone the other way on purpose. There are dragonfishes that produce red light and can see it, while almost nothing else can. They carry a private searchlight, invisible to their prey. It is a small, quiet advantage, and it works. The Twilight Zone is also where the great divers come. Sperm whales hunt here, and deeper. They can hold their breath for over an hour and descend beyond 1,000 meters routinely, and much further on occasion. On the way down, they stop moving and simply sink, saving energy, letting their lungs collapse under pressure in a way that is entirely normal for them and would be fatal for us. Down in the dark, they hunt by sound, sending out clicks and listening for what comes back. Their clicks are among the loudest sounds made by any animal. They are not the deep, mournful songs people usually imagine. They are sharp, mechanical, patient. Click, click, click. Somewhere below, a squid is located. Elephant seals do this too, diving for 20 minutes at a time, over and over for months, sleeping in short spirals as they sink. Between all of this, the fish of the Twilight Zone go about a small and unglamorous life. Bristlemouths, tiny fish barely a few centimeters long, may be the most numerous vertebrates on the planet, not the most numerous fish, the most numerous animals with a backbone. Trillions of them, quietly in the middle water, and almost no one has ever seen one. It is worth sitting with that for a moment. The most common backboned animal on Earth is a small dark fish in the Twilight Zone, and it has no common name that anyone uses. At the bottom of this layer, around 1,000 meters, the last of the surface light finally gives out. Below this point, every photon in the ocean is made by something alive. From about 1,000 meters to 4,000, the ocean is in permanent, total darkness. This is the midnight zone, the bathypelagic. It is, by volume, one of the largest habitats on the planet. Not one of the largest in the sea. On the planet. Most of the living space on Earth is cold, black water, and it is here. The temperature has settled to about 4 degrees, and it will stay near that for the rest of the way down. The pressure is now over 100 times what you feel at the surface. There is no season here, no day, no storm reaches this far. The water moves, but slowly. Currents at this depth can take 1,000 years to circle the world. And through all of it, endlessly, quietly, something is falling. It is called marine snow. Everything that dies in the sunlit water eventually comes apart. Plankton, fish scales, fragments of jellyfish, the shells of tiny organisms, the waste of everything that ate anything. It clumps together into soft, pale flakes and begins to sink. The flakes are small, usually smaller than a grain of rice, though sometimes they gather into larger, looser aggregates. They fall slowly, at speeds measured in tens of meters per day. A flake that leaves the surface today may take weeks to reach the deep floor. And some of it never gets there at all because it is eaten on the way down. Seen from a submersible light, it looks exactly like a snowstorm in a headlight beam, except it never stops. It has been snowing here for hundreds of millions of years. That falling material is the entire economy of the deep sea. Nothing down here can photosynthesize. Almost everything below 1,000 meters is living, directly or indirectly, on what drifts down from the sunlit skin far above. The deep ocean is a place that eats leftovers, patiently, forever. Because food is scarce, the animals here have made a series of very reasonable decisions. They are mostly small. They move slowly or hardly at all. Many have soft, watery bodies because muscle is expensive and there is nothing to run from that they could outrun anyway. Their metabolisms are slow. Some can go months between meals. And a great many of them have solved the problem of finding food in the dark by not looking for it. They wait. The anglerfishes are the famous example, though almost every picture you have seen of one is misleading. In photographs, they look like monsters. In life, They are usually smaller than your hand, and they hang motionless in the black, doing nothing at all for a very long time. Above the mouth is a modified spine with a small glowing lure on the end. The light is not made by the fish itself, but by bacteria living inside the lure, in an arrangement that seems to suit both of them. The fish twitches the lure gently. Something small comes to look. That is the entire hunting strategy, and it works well enough that anglerfishes have been doing it for tens of millions of years. Male anglerfish, in some species, are tiny, a fraction of the female's size. And their story is one of the stranger things in biology. They find a female in the dark, bite on and fuse. Their tissues merge with hers. They lose their eyes and most of their organs and continue as a small permanent attachment, providing what she needs and receiving what he needs. Whether this is bleak or peaceful is a matter of taste. It is certainly efficient. There are other quiet residents, gulper eels, which are mostly mouth, a huge hinged jaw on a thin whip of a body, so they can swallow something larger than themselves on the rare occasion that something larger arrives. Barrel eyes with transparent heads. Their tubular eyes point upward through their own clear foreheads, watching for silhouettes above, and can rotate forward when it is time to eat. Vampire squid, which despite the name, eat almost nothing but marine snow, sweeping it up with long, thin filaments. They are gentle, small, and when startled, they turn themselves inside out and glow. And then, occasionally, something enormous falls. When a whale dies, its body sinks. On the deep floor, this is called a whale fall, and for the deep sea, it is a windfall on a scale nothing else can match. Several tons of food arriving at once in a place where a fish scale is a meal. The sequence that follows is well documented and takes decades. First, scavengers arrive within hours. Hagfish, sleeper sharks, crabs, and strip the soft tissue over months or a year. Then a community of worms and mollusks works through what has settled into the sediment. Finally, for years and sometimes decades, bacteria break down the bones themselves, releasing sulfides, and an entire small ecosystem lives on that chemistry alone. There are worms that specialize in whale bone and are found nowhere else. Their larvae must drift through the black water, waiting for another whale to die somewhere within reach. It is an existence built entirely on rare, enormous luck, and it has been working for a very long time. Somewhere in this ocean, right now, that process is happening on a seafloor no one has ever visited. Below 4,000 meters, the water finally reaches the floor. Most of it is flat. This is the strangest thing about the ocean and the thing that maps never quite convey. The abyssal plains are the flattest surfaces on Earth. Flatter than any desert, flatter than any frozen lake. They cover something like half of the planet's entire surface. Half. More of Earth is quiet, level, sediment-covered abyssal plain than is land. The reason for the flatness is time. The rock beneath is volcanic and uneven, but it has been raining sediment onto that rock for tens of millions of years. Marine snow, dust blown from continents, the microscopic shells of surface organisms. And the sediment has slowly filled every hollow and softened every edge. The floor is buried under hundreds of meters of it in places. It accumulates at a rate of a few centimeters per 1,000 years. Put another way, the top centimeter of mud on the abyssal plain is roughly as old as recorded human history. Walking on it would not be possible in the usual sense. It is extremely soft, closer to a thick pudding than to sand. Submersibles that touch down raise a slow cloud that can take hours to settle because there is no current to carry it and no turbulence to break it up. The light from a submersible is the first light this particular patch of ground has ever received. Not the first in a long time, the first. That sediment has been in absolute darkness since it was laid down. What lives here is sparse and unhurried. Sea cucumbers move across the mud, eating it, digesting the small amount of organic material within it and leaving it behind. They are the earthworms of the abyss, and there are a great many of them. Some species have been filmed drifting just above the floor, using flaps of tissue to travel a little way before settling again. Brittle stars lie in loose arrangements, arms spread. Sea pens, soft feathery colonies, stand rooted in the mud like something from a garden, filtering whatever the slow water brings. Xenophyophores live here too, and they are worth a mention because they are strange even by deep-sea standards. Single-celled organisms that can grow to the size of your palm. One cell, visible from a meter away. They build fragile structures out of sediment grains and sit there, doing very little for what may be a very long time. There are tracks in the mud everywhere. Furrows, spirals, small neat rows of holes. Some of them were made recently, some are much older, because with no waves and almost no current, a track can stay legible on the abyssal plain for years. The floor keeps a record of its own quiet traffic. Above all of it, the water hangs almost motionless. Almost. There is circulation down here, but on a time scale that is difficult to feel. Cold, dense water forms at the surface near the poles, in the North Atlantic and around Antarctica, becomes heavy with salt as sea ice forms and sinks. That water spreads along the bottom of the world, creeping across the abyssal plains for centuries before rising again somewhere else. The water at the bottom of the Pacific has not touched the atmosphere for something on the order of 1,000 years. It sank when the great medieval cathedrals were being planned. And it has been down there in the dark ever since, moving at the pace of a slow walk per day. Sound, though, moves easily. There is a layer in the deep ocean where sound travels extremely far, sometimes called the Deep Sound Channel. Low-frequency noise entering it can carry for thousands of kilometers. Whale calls made off one continent have been detected near another. The ocean, which looks like the most isolating place imaginable, is acoustically one of the best connected environments on the planet. So the Abyssal Plain is dark and still, but it is not silent. It is full of distant, low sound. The groan of ice at the poles, storms overhead, earthquakes in the crust. The calls of animals hundreds of kilometers away. All of it arriving softly and passing through. If you sat on the floor of the abyss and listened, you would hear the whole ocean at once, very faintly, all the time. In 1977, a small submersible called Alvin was working near the Galapagos Rift, about 2.5 kilometers down. The scientists on board were geologists. They had come to look at the sea floor spreading, the place where new crust is made, where the plates pull apart and magma rises to fill the gap. They expected rock. They expected almost no life because they were far below the reach of sunlight, and they knew what the deep floor looked like: sparse, thin, patient. What they found instead was a crowd. Around cracks in the rock, warm water was pouring out, shimmering, mineral-heavy and hot. And clustered around those cracks was more life per square meter than anyone had seen in the deep sea. White crabs, mussels in dense beds, clams the size of dinner plates, and stands of tube worms over 1 meter tall with bright red plumes. They had no biologist on the first dive. The story goes that they had to preserve specimens in vodka from the ship's stores because they had not brought the right chemicals. They had not expected to need them. The discovery rearranged a basic assumption. Until then, the working idea was that all life on Earth ultimately runs on sunlight. Plants capture it. Everything else eats plants or eats something that did. The deep sea survived on scraps falling from the sunlit surface, but nothing was falling from the surface fast enough to feed this. And the animals here were not thin and slow like the rest of the abyss. They were thriving. The answer was in the water itself. Seawater seeps down through cracks in the young volcanic crust, gets heated by the magma below, sometimes to hundreds of degrees, and dissolves minerals from the rock. Then it rises back out through the vents, loaded with chemicals, in particular hydrogen sulfide. When that hot mineral water hits the near-freezing seawater, the minerals crash out of solution as fine dark particles, which is why some vents look like chimneys pouring black smoke. Hydrogen sulfide is poisonous to most life, but there are bacteria that can use it, that can pull energy out of those chemical bonds the way a plant pulls energy out of light. The process is called chemosynthesis, and it means an ecosystem can be built with no sunlight involved at any step. The tube worms took this further than anyone expected. An adult tube worm has no mouth, no gut, and no anus. It does not eat. Inside its body is an organ packed with billions of these bacteria. The worm's red plume, the color, comes from hemoglobin, the same molecule that makes your blood red, absorbs hydrogen sulfide and oxygen from the water and delivers both to the bacteria inside. The bacteria produce food. The worm grows. It is a partnership so complete that it is difficult to say where one organism ends. The whole arrangement is temporary, which is the part that stays with you. A vent field is fed by geology, and geology shifts. Cracks seal, magma moves. A vent that has supported a dense community for decades can go cold in a matter of months, and everything living on it dies. So the vent animals live like the whalefall worms. Their larvae drift out into the enormous dark, carried by slow currents, most of them finding nothing at all. A few of them arriving at some new crack in the crust that has just begun to leak warm water. And they settle there, and a crowd assembles again, in a place that had been empty rock a year earlier. There are other seeps too, cold ones where methane leaks slowly from the sediment, supporting their own quieter communities that can persist for far longer. The deep sea, it turns out, is not one habitat. It is a mostly empty plain with occasional islands of plenty, scattered unpredictably, each one temporary, connected only by drifting larvae and time. Some researchers think life on Earth may have started somewhere like this. The reasoning is that a warm, mineral-rich, chemically active crack in the rock offers energy and shelter without needing an atmosphere or a sun. It is not settled, and it may never be. But it is a quiet thought that everything alive might trace back to a warm seam in the dark, and that such seams are still out there, still working right now. There is one more layer. In a few places, the seafloor does not stay flat. Where one tectonic plate slides beneath another, the crust bends down and forms a trench, a long, narrow gash in the floor of the world. Below 6,000 meters, this is called the Abyssal Zone, named after Hades. It makes up a very small fraction of the ocean by area, but it contains its deepest points, and they are deeper than most people picture. The deepest known place is in the Mariana Trench in the Western Pacific, a small basin called Challenger Deep, at roughly 11 kilometers down. Some comparisons help, though nothing quite conveys it. If you placed Mount Everest at the bottom of Challenger Deep, its summit would still be more than 2 kilometers underwater. The trench is deeper than commercial aircraft fly high. The pressure at the bottom is around 1,000 times what you feel at sea level. That is often described as an elephant standing on your thumbnail, or a ton pressing on every few square centimeters. Metal spheres built to go down there are machined to extraordinary tolerances and still compress measurably on the way. The whole vessel shrinks slightly and then relaxes on the way back up. Very few people have been to the bottom. 2 men made the first descent in 1960 in a vessel called Trieste and spent about 20 minutes on the floor. They had stirred up so much sediment they could barely see, and one of their outer windows had cracked on the way down. The next crewed descent did not happen until 2012. In recent years, a handful more have gone, some of them repeatedly. What they found is not dramatic. That is worth saying plainly, because the trenches are usually described in the language of horror, and the reality is gentler. There is fine, pale sediment. There are small, translucent amphipods, shrimp-like scavengers a few centimeters long, in surprising numbers because trenches act as funnels and collect whatever sinks from the wide water above. There are sea cucumbers. There are single-celled organisms in the mud. Snailfish, small, pale, soft-bodied, almost translucent, have been filmed at around 8 kilometers down, calmly going about their business. They appear to be near the physical limit for a fish, and they look entirely unbothered by it. There is no monster. There has never been a monster. There is a soft, pale fish moving slowly, eating things that fell. There is also, unfortunately, us. Plastic has been found at the bottom of the Mariana Trench. A plastic bag was filmed on the seafloor of Challenger Deep. Amphipods collected from the Abyssal Zone have been found with man-made chemicals in their tissue at concentrations that are hard to read about calmly. Pollutants banned decades ago, drifting down as marine snow, concentrating in the animals of the deepest place on Earth. It is a strange kind of intimacy. We have visited the bottom of the ocean perhaps 24 times in all of history. Our rubbish has been more often. That is not said to trouble you tonight. It is said because it is true, and because the deep sea spent 4 billion years being entirely untouched. And the last part of its story is very short and very recent. The trenches will outlast it. They are, after all, holes made by continents moving. Given enough time, the plate now sliding into the Mariana Trench will carry that sediment and everything in it down into the mantle, and the record will be melted and returned to the rock. The ocean recycles slowly, but it does recycle. We have come a long way down, through the moonlit swells, past the animals that rise every night and sink before dawn, through the twilight, where things are silver or transparent or carry small lights on their bellies so that they do not cast a shadow, through the long black middle of the world, where it snows endlessly and something waits patiently with a lamp, across the flat, quiet plain that covers half the planet, past the warm cracks where life runs on chemistry instead of sunlight, and down into the deepest trench, where a pale, soft fish is moving slowly through water that has not seen the sky in 1,000 years. All of it is happening right now, while you lie there. None of it needs anything from you. The particle that left the surface today will still be falling next week. It is in no hurry, and neither tonight are you. Whatever is unfinished can wait until morning. The ocean has waited longer. The pictures will drift for a while. There is nothing more to listen to. Good night.